Let's talk about LeetCode 1714, sum of spatial evenly spaced element in array. It gives us an integer array and also a two-dimensional array queries. So what does a query do is that the query, every element of the query is the query. The first one is the start index. And the second one is the step. Actually, that means you'll see from i's element from we should have uh, sum up those kind of number j from I, and j minus xi is divisible by yi. So what does that mean? Is that we need to, for example, this is this is xi, that is the starting index, and the step is 3. That means we are going to add nums 0 to nums 1, 2, 3. So every time we pick up a step with the y, and then to this, right? So the sum will be 0 plus 3 plus 6 will be 9. So it asks to return an array for those kind of queries. Um, so this problem, the thing is that if we're thinking about brute force, right? Brute force way for those kind of queries, if there are m query, and for every query it starts, for example, around 0 or some kind of index xi, right? And it the yi is the jump steps, right? The kind of width. Or, so if we do brute force, if this kind of step is very small, for example, it is every time it um just um, um jump for one index, then for every query, uh, that means we are going to sum with, for example, this is n divided by yi, right? And so if this small, it is close to n, right? And if there are um, m queries, then that will be m multiplied by this kind of nums length divided by yi, right? And then also multiplied by the queries. So if this step is very small, you see there is this kind of, it will be close to m multiplied by n, query length multiplied by number length. And you'll see this num is 5 to the power 4th. And in the query is also a big number, right? So if we have this one multiplied by this, it will of course be TRE. So we should have so that for this one, we'll see if this kind of step is kind of, if this is big, a bigger number. For example, this is 5 to the power 10th, right? For example, if we have a yi to be 10 to the power fourth. For every query, we just need to sum up up to 5 numbers. So if this y is very big, this will be some kind of small number, so that will not be TRE, right? So the thing is that for this kind of small numbers of y, how can we handle that? Actually, we can pre-processing. We'll see, because this kind of number we are adding from our index xi, right? Every time we jump yi steps to xi plus yi, right? Um, and until to the end, right? So every time we jump this kind of step, um, we can pre-processing. For example, this yi. For example, we get a limit, right? So every yi smaller than this kind of limit, we do processing. If it is greater than this kind of limit, we do brute force. So if this yi, for example, smaller than this one, we can have an dpi limit, right? Then we know from the um, we that is from index I to the end with the step if dp ij means from for step j add to the end what is the sum, right? So we know if there is a dp ij, we have this number, right? We can know the dp I minus j, right? That will just add the nums I minus j well, to the dpij, right? So we can pre-processing for those kind of smaller, small steps one, create a dp array, right? So how can we choose the limit that a small number are to be using pre-processing and a bigger Y we use brute force. Let's analysis the time complexity, right? If brute force, that will be n divided by yi multiplied by m, right? And if we pre-processing, that will be we are open n um, to the limit, right? And multiple by limit, right? So what we need is that we want these two be similar, right? So what we're thinking about is that we can have this kind of limit to be the square root of n, right? So that means this y that is the limit, right? So that will n divided by square root of n multiplied by m, right? So that the time complexity will be close. So let's write code for this. So you say that the result need to mod this kind of number, right? So private final static int mod equals 1 0 0 0 0 0 0 7. So int a equals nums dot length, and so we are going to have a limit called r equals int. Actually, this is just a estimate square root n. Um, so what we do is that we'll have long called dp equals new long n. We'll have r, right? Then what we do is that for int I equals n minus 1, I greater equal to 0. So dpij means from index I, we have a step j, those kind of sum adding to the end, right? So I minus, right? And then we're going to have for int j equals 0, j smaller than r, j plus plus. So what we do is that we know that dpij will be nums. Then we going to add the dpi I plus j, right? So if I plus j is smaller than n, then we're going to have dp I equals ij equals dp I j plus dp I plus j, and we need to have mod. So let's see, also we have a chorus, right? So if int m equals chorus data length, so what we do is that we are going to have result equals new int um m. So we do that for int I equals 0, I smaller than m, I plus plus. Um, so int chorus equals chorus I, right? So we know int x equals array 0 and y equals array 1, right? So what we do is that if y is smaller than r, then we can just checking this kind of pre-processing setting result, right? So we're going to have result I is equal to, let's convert this one to int dp x y, right? Else, else that means that is y is kind of big, right? We can do brute force. So, mm, so what we do is that for int j equals x, j is smaller than n, j plus equal to y, right? Then this result, this is int. Let's use a long, right? Long v equals 0. And so that v equals v plus nums j, and we have mod, right? And just a result I equals int v. In the end, we just return results. If we can also write a Python code for this as well. So we know if those kind of y, the step is small, we need a pre-process. So we have n equals length nums, and let's have r. What is r? R would be uh int. Let's just use a new line. R equals int a, right? So we're going to have a dp, right? dp equals this one, multiple by R for this one in range A, right? So for I in range A minus 1, we need to go to end with 0 inclusive, right? Yeah, and minus 1. For J in range R, so what do we do is that the dpi J equals nums I. So if I plus J is smaller than N, right, then we're going to have dpi J equals dpi J plus dpi plus J and mod. So let's define mod equals so let's have a result. By the way, this that for x, y in queries, if y is smaller than r, then we just need to check the dp, right? Result should append dp x y else else uh, else we are going to have we also have nv equals to 0, right? Um, and so we need an index. Let's have index j equals x, right? So where the yj is smaller than n, we have v equals v plus nums j and mod, and also every time we j should increase by v, right? And by y, this is step. And after this while loop, we just have result append v. So this is for y is big, right? And in the end, we just return result. So the we'll see. We put this kind of queries into two parts. For those kind of y, when it is small, right? If we use brute force, the value will be similar to close to the query length multiplied by the norm length. That will be kind of better performance, right? And so for the small number, we do pre-processing. So this kind of part, we have an n square root n time complexity, right? And because we have a just put this kind of r to be square root. And for this one, brute force one, right? Because we are from this y is from square root n, right? So for every query, it is n divided by square root sum of those kind of number. So that will multiply by m. This is also a square root n, right? So the time complexity will be n square root n plus m square root n, right? And for the space, this is n square root n, and this is n m, right? So space is n square root n plus m. A time complex is n square root n plus m square root m n.